The application will crash.
Oh, did it?
Yeah. Second.
I mean, I got the voice recording.
You got it?
Yeah, but no video.
You got very durable.
That's cool. What?
Can you see?
I got it, yeah.
It works?
But everything's like this. So we all have to like look at like that.
Can you just make it stand
Huh?
up? Can make it stand up?
Can make what? Like this? You can.
Why don't you do it? Do you want me to hold it again?
1 second. Oh,
Here, I'll put it right here.
I think it's good now.
I think it's actually really time.
As long as there's no one touch it.
Okay.
It's good, right? It's good now. This computer is in the. Can you please walk? Like, move back.
Like, move this.
I can just put it right here.
Just so we get like both sides.
Right. Oh, sorry.
How's that?
This one?
That's good. That's good.
That's good, Sen. Good, Sen. Yeah. Break it.
Just rip it off.
Just rip it off. Take hold. Sell it. Yeah.
This way is better.
Is it better? Are you gonna hold it?
We gotta hold it.
Sure. Do it like this. Make it anchor like this.
Isn't this better?
Are you sure?
Good morning, folks. We're going to pick up where we left off on Monday with designing that class for rectangle objects. So go ahead and get that file open on your machine. If you were not here or did not save that code somehow, I'm dragging the file that I developed on my side onto the canvas right now, and I'll put it up there. So go ahead and get yourself an IDE open. And I'll be putting that file there right now. You can see where we go.
You offered it.
Let me borrow your book.
Well, okay.
Perfect.
You hope? Oh, yeah, exactly.
You're not going to use this computer, right?
I'm not gonna use it.
So for those of you copying the file that we had developed together here, which may have a thing or two more than what you had on it, but it's in files, example source code, and in classes, and then the name of the file is classes 00-fall 17. So what we'll do in today's session is go through what a constructor is. We talked about that on Monday. It's a special kind of function to build the object when you instantiate objects of the class. And then we'll code a constructor together. And we'll talk about a couple of other best practices for designing those member functions called mutators and accessors, which we introduced on Monday. And then we'll break into sort of a group problem solving session where you can work on the assignment, for the class's assignment, on developing the money class. So let's pick up where we left off. Let's see. All right. So we, as we'll kind of walk through what we did again with the class, right? Remember, with classes, we're designing a blueprint that's a new data type, really. You can make, we talked about you can create variables of data type integer or string or double. And it's possible for you to now create your own data type. called a class. So string, remember we talked about the difference between a simple data type, like int or double, and a non-simple type like string, which has these extra features and cool things it can do, like process the string, tell you how long it is, find certain characters and stuff like that. And that's because the string is designed as a class. Here we're looking at how we can design our own data types using a class design. And what you do is you design kind of the blueprint of what you want the data type to be like. Remember, classes define objects. All objects have both properties, or data members, and the second thing is behaviors, or functions that they can do. And we looked at the UML diagram for this class rectangle we created to create rectangle objects. And a rectangle, its properties are its dimensions, its width and its height. The kinds of behaviors that we might add to a rectangle object, things that it can do, would be things like to set the values of the width and the height, or another function to find out what the area is of a rectangle. We talked about the difference between privacy access, that you had two designators, public designator and a private designator. Anything you put in private, only things of the class can access that. And we haven't really explored that yet. Let's do that today. We'll go ahead and try to access some of these things and find out that we cannot from outside of the class, like in main. Anything you put in public is accessible outside of main, or outside of the class, in other words, like in main. So these member functions, we started calling these in main last time, and we were okay to do so. We could even change the color of the object if we wanted to, and that would be okay. But we cannot change any private members. So if we were looking at main, and we made a rectangle called R1, like we did in our code last time. Remember, if you're looking at the code that I just published for you, which let me change my color real quick. Remember that we made some rectangle objects, R1, and oh, sorry, I'm still getting used to this computer. I guess I have to exit presentation mode to actually see this. So, okay, so we made some rectangle objects in main. This is what we did on Monday. And then we even called these member functions out in main, r1.area, r2.area. We made another member function called an accessor that gets the height. It accesses and retrieves the height of the rectangle. We're allowed to call that out in main. Because all of these member functions are placed in the private area. If we had put them in, let's say you instead had taken, just do this right now, take the member function for area, double area, take it in lines 21 and 22, and move it down to private. If you try to build this code now, let me just make sure I've got the right build settings. Yep. So if I try to build this code at this point, I'm going to get an error message. And you notice that it's pointing to area. And it says, it's pointing to area right here, right there. And it says over here, error with this within this context, area is a private member function. So you can't call it outside of the class. We'll look at when you would want, so a question might be, oh, why would I want to make a private member function? We'll look at some examples of that a little bit later. Okay, so let's take that area member function and undo, just do a Control-Z a couple of times, or copy and paste and put it back in the private area, in the public area. Now, remember we made a public data member called color. Because that's public, we can actually change it outside in main. So if you wanted to do this and you wanted to say something like, r1.color equals purple. And you build that, you're good to go. This is allowable because color, the color property, is a public member function. However, and you could change it to whatever else you wanted, right? So change it to something else. But however, what if you said r1.width equals 10? You want to try to change the width of rectangle 1. Go ahead and build that, and you'll see that you get an error message. It says rectangle width is private. This is a private variable that you can't adjust outside the main. At first glance, this might, so I guess what we're seeing then is that this generates an error. You try to access a private member, this will give you a compiler error. And if you access public members, that's okay. At first glance, this feels like, wait, why would I want to make anything private now that I have to just go and design extra functions like set values to go actually and change the width and the height, or set width to change the width and the height. When all I want to do is change the width, why don't I just put width into public and then I can change it just like this, right? That might be a question as you're first looking at classes for the first time. And the reason why we impose this constraint, this limitation, is so you protect the data of the object. If width is made public and any piece of code can come by and change its value, then any piece of software can go and mingle and change the object. When we design objects and classes, we want to actually set the standard for when and how those objects are changed, and what are their parameters. For example, maybe your rectangle, like the world that you're creating in software, imagine you're writing a computer programming game, and this rectangle object, which is some kind of, entity that lives in the game, cannot grow beyond a certain width. Maybe the screen is a certain number of pixels long, right? And you don't want to be able to make rectangles that can get any bigger than that, right? So you can actually impose those limitations inside of your code. So let's go here. Let's take this line of code out of there. We don't want to do that. What we want to do is do something like r1.set width to 10. And this is an approved channel to change the object. Why is it approved? Quote, approved because set width is a member function. Well, I need to capitalize that W, so I'll capitalize it right now. But set width is a member function of the class rectangle. It controls how the width is changed. Do we already write a set width? It looks like we, at least in my files, I put in a placeholder for the function. We declared the function, but now we need to actually define the function. So let's do that. Let's write set width, and let's also impose the constraint